most people have probably seen the recent update that we did where actually let me just hop back into home just to show you guys where we added some more settings over here to change certain things about your model. Now, these are more advanced settings, so I would caution to not really change this unless you know what you're doing, because it does have some consequences, which I'll explain each of them in this video. Um, with that said, hopefully this video will teach you exactly what each of these do so that you're going to be able to use it very effectively. Um, there are more AI settings coming down the road that we're currently working on. I don't want to say what they are, but they're very exciting. So just keep a lookout for those. But for now, I'm just going to explain these. The two big things to explain is the concept of probabilistic actions, right? And then the other one of this exponential memory updating. This one is probably, even though we have an explanation here, I'm gonna show you guys a video, not a video, a visual that I coded up that hopefully will make this clearer. But let's start with the probabilistic actions because these, I think, at least people have more intuition into how this works. Um, so let me actually draw up something um, just to provide context for those who don't know. I know some people will already know this, so this will be kind of like repeat for them. But for those who don't know, let me just draw up something here for you. So the way that things work in our game is that each frame, right, and there are 60 frames per second, but each frame, the AI takes a snapshot of the environment, right? So let's say, for example, this is our environment. We have like our like stages over here, right? We have like our characters. Maybe this character's like flying through the air. Um, and like, yeah, and then you can have like projectiles and whatever. But um, essentially what happens is each frame, the AI looks at the environment, right? It then converts this into something called a state. Okay. Now, a state is just a bunch of numbers that represent what's going on, that represent um, a snapshot of the environment. Okay. So a snapshot, by that I mean it's at this specific point in time, at this specific frame, what is going on, right? So as you guys know, some of these features in the state include the distance to the opponent, the angle to the opponent, the rate cast, all that stuff. So what we're doing is each frame, we're taking a snapshot of this, we're computing all these numbers, and that gets represented in this state, right? It's just basically a big list of numbers, okay? That state then gets passed into the model, right? In this case, it's a neural network model. And the model looks kind of something like this, where it takes some input, right? This is the state, has a bunch of neurons in here, right? It goes into, we'll just call this the layers, right? The hidden layers of the network, right? Where there's like a bunch of like interconnected layers. They all like connect to each other, and then this, oops, and then this eventually goes to the output, which is the actions. And we have two actions, as you guys know, right? We have the directions, right? So we have the directions, and then we have the combat actions. Okay. And what this output looks like, it's an array or a list of numbers that represent some probability, right? So we can have 0 0.3, 0 0.4, 0 0.2, and then 0 0.1, right? As an example. You can also have like another list. I'm not going to write it out over here for combat, but we have two separate lists of probabilities for which direction to take and which combat action or other button to press. Okay. Now, a more visual representation of this would look something like this. So this can be action number 1, action number 2, action number 3, and action number 4, right? So if we just write these out over here, then it might look something like this, right? Where this is basically the output. Now, in the probabilistic um, view, right? So if I just if I just switch back over to here, and in the options over here, when probabilistic actions are turned on, what's going to happen? What's going to happen is that you see how this is 0.3? That means that this is going to be a 30% chance of selecting this action. This is a 40% chance of selecting this action. This is a 20% chance of selecting this action. This is a 10% chance. This is when probabilities are turned on. Okay, so on. When the probabilistic selection is turned off, what this turns into is 0%, 100%, 0%, and 0%. The reason for this is because we only care about selecting the action with the highest probability, right? So it changes from probabilistic to deterministic, i.e., you always know what it's going to select in a given state, right? So in this state, the output is this. Therefore, every single time it'll always select action number two. Okay? So just want to reiterate. So when it's deterministic, this is the action that's selected. Always number two. When it's probabilistic, there's only a 40% chance of selecting action number two. Now, the question is, why would we ever want to do probability, right? If we're training a model to do a certain action, we want it to increase the probability of that because we always want it to do that in that state, right? Um, yes and no. There's pros and cons to being deterministic. One is that you always know what's going to happen, and so you train your AI to behave a certain way in that scenario. But there are some cons, and I'll give you two of them. One is that you can't confuse the opponent because then you start becoming predictable, right? You can imagine a scenario in very high level where your AI is very predictable, and then someone that specifically wants to target your AI starts to understand what it'll do in every situation, right? And then it'll specifically train to beat your AI in those situations, right? And so it's good to have a mix up. So maybe you're like, okay, most of the time I want to do this, but I want to also mix it up with this other action, right? Um, a good example of this actually is, let's say I draw like a floor over here and your character is over here. And then there's the character above that's doing the, um, it's gonna be a horrible drawing, but like you know that the down air, right? They're right on top of you. They're doing the down air, right? Directional. Let's say you wanted to train your AI to like move away from it, and so you train it to move to the right. Well, if you always train it to move to the right, then the opponent could actually start understanding that, and then it can always move to the right when it reaches a certain height because it knows you're always going to move to the right, right? But let's say you had this as like 60% probability and this as like 40% probability. Now you can mix it up so that the opponent actually doesn't know where you're going to go, right? But if it's deterministic, then it always selects this action and you become a lot more predictable. Okay, um, that's one of the big cons. The other is that it's it's not as visually exciting, right? So another example I'll give you, and it does actually limit some combos. So let's say this is you, and then this is the opponent, right? And then the first thing you do is like you're gonna kind of attack it, and if you're always pressing that, if you're always going in this direction, you're always gonna do the exact same attack, right? But maybe what you want to do is do that attack and then follow it up with an uppercut, right? But if you're in a very similar state, what's gonna happen is the direction is kind of always gonna be going to the right, or at least this is gonna be like 60% of the right, and maybe up is only like 10%, right? And so it's going to be very well in deterministic. You're never going to sample up, so you're never going to do a mix up of like attack and then into uppercut. But if it's probabilistic, now there is some probability of doing this, right? So it also makes for a more engaging combo game. Okay. And I think that's more akin to how humans think as well, is that there are certain probabilities that they're going to do this or this in this state, and then they're going to mix it up, right? So those are some of the pros and cons, and that's kind of like how this toggle works. Does anyone have any questions on this?
So far, so good.
Okay, cool, cool. Sorry, were you gonna say something?
No, no, no.
Cool. Okay, so let's get into this. I want to actually show you guys this in practice. So if I hop into the inspector, you see that um, I guess, oh, this is the trained AI, but we're just going to override it because we can always restore a model later. So I'm just going to train against the dummy for now. And I'm just going to teach it something very simple. I'm just going to do uppercut, just on stop. That's all I'm going to show it. And I'm going to hop into training in Fig over here. I'm just going to turn lambda all the way down because I just want it to learn to do the uppercut. And so I'll just train the model. Cool. And you see it increased the probability of attack and up a lot, right? Regardless of the scenario, that's going to be the dominant action. Now, what I want you guys to pay attention to is that it is the dominant action, but it's not 100% probability that you're going to select uppercut. There is some small probabilities in terms of some of the other stuff like jump, shield, grab, and special. Okay. Just want you to keep that in mind. I'm just going to save over here. And right now we have, I just want to double check over here. We have probabilities turned on. Okay. So let's see how that looks. So I'm just going to select my AI as the opponent just so I can see what it actually does. And it should, yeah, it's mostly doing uppercuts, but you see it mixes it up as well because there's some other probability of doing some other stuff. Okay. This is very important. So this is what the probability turned on. Even move to the left because there was some small probability of moving to the left. Okay. Now I'm going to go back home. I'm going to go into the settings and I'm going to turn these off. Okay. So now it's selecting actions deterministically. I'm going to save this, hop back into training. I'm going to select my AI again just to see what it does. And again, I'm not moving. I'm just letting it do its thing. And if I hop back into here, you see it's only going to do the uppercut. It's not going to do anything else because it's selecting the actions deterministically. Even though there's some probability of taking other stuff, it's ignoring it because it's saying, I'm only going to select the action with the highest probability, and that's the uppercut. Okay, I'm just going to stop over here because I think that kind of showcased the point. Um, I personally like having the probabilities turned on. But the reason why I give you guys the option and the reason why I separate it is because sometimes you might want to keep the combat probabilities maybe off and the directions turned on, right? To mix up the directions or the other way around. And we give you full control in terms of what you want to select probabilistically and what you want to select deterministically. And I think this is going to add another layer because I was looking through some of the user feedback and some people would like for directions, for example, to be selected deterministically, right? They know that they're always going to do this to get back onto stage, for example. But other people want it selected probabilistically to mix up their combo game. So we just give you guys full control over some of your AI's configurations. Um, I like both of them turned on, so I'm just going to keep it this way. But yeah, we just wanted to give you guys that option. Does anyone have any questions on this?
No, but I got a question for myself.
Yeah.
So for the toggle on and off, the application is to individual training configuration, or does it reset something that the AI has previously learned?
It doesn't reset anything that the AI has learned. It's just the individual configuration for the specific fighter. Each fighter will have its own configuration, right? So just because I change it on this fighter doesn't mean it applies to your other fighters. So for example, um, I have a few fighters. So for example, if I put off and off for this fighter, I'll save it, and then I select one of my other fighters, this girl over here. I hop into here. You see that it's different, right?
Hmm.
Because we allow you to configure each individual fighter specifically. And it doesn't alter the training. Literally all it does, like this remains the same. It just impacts how the actions are selected given the current model. Does that make sense?
Yes. So theoretically, I just want to bring out the point that we can apply this on and off like in different phases of the training to kind
That
of
is
like fine
correct.
tune. Yes,
That is correct.
interesting.
One thing I will note is that this just applies to your training model. It doesn't get applied to your finalized model until you finalize. Um, I might have to look into the code again just to verify this, but I'm pretty sure that's the case. Um, we
Understood.
might be, yeah, because yeah, if you modify that, then it also changes the model hash. Um, and so you just have to do the whole finalization process. But if people feel strongly about us doing it a different way, we can apply it globally, but it'll just take a bit more work. Anyway, yeah, just wanted to bring that up.
Got it. Got it.
Cool, cool. You guys ready for the next part? This is the a slightly more challenging part to understand this concept of memory updating. But I will try to do my best to explain it. And I wrote some code just to visualize it for you guys. So if you're ready, I can switch over. Okay, so what I'll do is I'll erase all this stuff over here. Um, I wrote some Python code to show you guys, but before that, I just want to draw something out. So basically, we have draw. So I think you guys are aware. I'll try not to make it too technical in terms of like a visual, but you guys are aware that you have some model. Let's call it like model one, right? You get some data. Let's call it like data set one. And then once you get the data, right? So you want to alter the model to turn it into like model two, right? Um, but you don't want to really forget what happened in model one, right? You still want to remember it. And so what we do is we have this thing called lambda, right? Which kind of regulates how much so now basically you take lambda into account. You take lambda and your data set into account when making model 2, and lambda basically regulates how much you want to remember from M1, okay? So just want to make that clear that lambda dictates how much you want to remember from M1. Now, there is actually a little step in here, we'll call it memory, okay? Memory directly feeds into the lambda. So lambda gets applied to this concept of a memory. So okay, so let's think about it this way, actually. Um, this might help. This might help. So let's say I'll just divide this thing into like four quadrants. This is purely for an explanation. This is not technically exactly how it works, but conceptually it's how it works. Okay. So let's say you spent most of your time training in this bottom left quadrant over here. Okay. Um, what will happen is that we will update this part of the memory, okay, to say, okay, I've spent a lot of time training on this left quadrant. I'm going to see, I'm going to see which part of the model this left quadrant corresponds to, okay? So if I draw out the neural network again, very simply, let's just say our neural network looked something like this, okay? So it looks like this. You have all these connections, right? Something that looks like that. What we do is we do some math. Let me select a different color. Let's say red. Do some math to calculate which part of the neural network corresponds, right, to this bottom left quadrant. To say, okay, this bottom left quadrant uses these neurons mainly. It mainly uses these neurons over here, okay? So then what we can do is we can say, okay, we use these neurons mainly, so this is the memory that corresponds to this bottom left quadrant. Okay, and over time, as we update more and more and more, we update this memory a lot more. Okay. Um, and so essentially what happens is, let's just say that we're trying to update our model and we have like, oops, this is too thick. And we have a lambda of 0. Okay. What that means when our lambda is 0, it's going to say, okay, I actually don't care about my memory. So I can ignore everything that we've done in the past with respect to this bottom left quadrant. Okay. This is not technically exactly true, but conceptually it's true to say that I don't want to be anchored to this bottom left quadrant specifically, okay? But if lambda, let's say, is like 0.5, it's going to regulate it and say, okay, I want you to pay attention to a certain extent to not forget this bottom left quadrant. And what that means basically is that each time we update the network, we're updating the entire network, okay? But this 0.5 is saying, okay, hold on a second. You can update all these other ones. I'll put them in blue. Um, you can update like this one, this one, this one, this one. You can update these a lot more easily because they don't have to do with what I just showed you in the bottom left quadrant. But the red ones, be very careful, okay? I'm gonna apply a penalty to you if you try and update these. Okay, that's conceptually how it works. And I know I'm getting a little technical over here, but I just wanted to explain this concept high level. Uh, just because if we don't understand this, then the next part won't make sense. And so what you can know is that this memory, you can think about this memory. Oh, sorry, it's thick again. Um, you can think about this memory as a list of numbers. So like 3, 4, -2. Actually, not -2. And whatever. So we have a list of numbers. And so what I'm going to show you now in code is that just an application to one of these specific numbers, but we do it to every single one of these numbers. Okay. Um, and what I'm specifically going to show you is how we update the memory, right? I think the toggle was called like exponential memory update, and it's just meaning that we're going to update the memory a lot faster. And if it's turned off, then we update the memory slower. And I'm going to show you the implications that this has. Okay, so let's get into it. I was showing Malcolm and Wei this this the other day. Let me just clear this, and it was like really nostalgic for me because it brings me back to my quant days. So if anyone wants this Python file, I'll send it over to them. But we're just going to use matplotlib just to plot the charts, and we're going to use NumPy just to generate the arrays. Okay. So we're going to import the packages, and the first thing we're going to do is we're going to create basically this like fake data, and this fake data is going to represent the memory as it's changing through time. Okay, or no, sorry, this isn't the memory. This is like your updates. Okay, and we're going to show you how we would update the memory accordingly. So let's say, for example, this is like what you did in the bottom left quadrant. Okay, and you did all these different things over here. Okay, and what we're going to do is we're going to update the memory. So you see that you did like very, very different things over here. Okay, so there are two basic ways that we update the memory. The one is a simple, what we call the simple approach. The other one is the exponential approach. Um, I will just plot them for you just so you can see the difference between the two. Okay, so you see that the simple approach gets anchored to the beginning heavily. And this example, this specific chart won't show you to its fullest. I'll show you in another example where there's clearly drift. But basically what happens is that we kind of like start off and it starts tracking it and then it kind of flat lines, right? Because the simple approach, what it does is it treats every data point as equal. Okay, so what that means is at point 50, each incremental new thing that's showing your model, right, at point 51, what it's going to do is it's going to update by a factor of 1 over 50, right? And at point 100, it's going to update by a factor of 1 over 100, right? So each new thing you show your AI, it impacts the overall memory less and less and less. okay? Because what we're doing is we want to treat all of them as equal. So each new incremental point is kind of like impacting the memory less and less. And so you see it kind of has the biggest impact at beginning because we have the fewest samples and it starts to flatline. Versus the exponential approach, this takes a different approach. The exponential approach basically says, no, I'm going to be changing my strategy over time. And so I want my model to be able to adapt. And you see that it follows what you show it a lot closer. So the memory starts tracking it a lot closer. Okay. I'm going to try and find another example where there's a clearer drift. This one has a decent drift, but I want a bigger drift here. So this is an example of basically you start off at a certain point, um, and your play style has really changed a lot, right? So you're showing it very different things over time. Okay. Now, if what I do is I plot the simple updating versus the exponential updating, you see a big difference, right? Because the simple updating gets anchored to the beginning a lot more because it's saying, okay, each new incremental data point is not super important. They all contribute equally to my memory. And so as this keeps moving up, this gets updated less and less and less, right? Because remember, this is now at point 100, it's updating at 1 over 100, right? And at point 1000, so the 1000th training session, it's going to be updating at 1 over 1000. So each new training session is barely going to impact your memory. And so what that means is that your memory is mostly impacted by what you show it at the beginning. Versus the exponential, you see it's keeping up really well, right? And as your play style is changing, the memory is starting to changing, right? And what that means is that it starts to forget what you showed it at the beginning. Like at point 100, it doesn't really remember what you showed it at the beginning. And so there are trade-offs between this. Now, you might be wondering, okay, what if I switch it at the halfway point, right? I start off with simple, then I switch it to exponential or the other way around. We'll show you what that looks like over here. So again, we have our simple and exponential. We saw those. But what happens if we start off at simple and then we switch to exponential? And this could be a case where you're like, okay, when I start, I want it really to anchor to the beginning. And you see that the play style starts to change and you're like, okay, my play style is really changing at this point. I'm going to switch to exponential because I want it to adapt to what I'm currently showing it, right? And you see how there's like a kink over here, right when the change happens. On the other hand, maybe you're like, okay, I was at exponential, right? I was following it closely, and I'm going to switch to simple right now, okay? Because I really like what I showed it here, so I want to anchor to that. And you see it starts to flatline after this point, right? Because it's getting anchored a lot to the beginning. And the reason why I wanted to give users the ability to toggle between the two is because I remember when I initially introduced the concept of memory and exclusive access, I asked everyone, I was like, hey guys, we're thinking of doing this. We can either do a simple approach or an exponential approach. And I got some initial feedback. It was really split. I ended up going with what the majority of people wanted, which was the simple. But I personally actually prefer the exponential. But it's just because most people wanted the simple. Um, and so what I ended up noticing though is it was getting very frustrating for me when I was training and using high lambdas because when I was using the simple and I was clearly changing my play style, what was happening is that it was making it really hard to learn because the lambdas were anchoring my model to what I showed it like literally a month ago, right? Because the memory was getting so anchored to that. And it was quite frustrating. And I was like, you know what? I'm just going to introduce a toggle so that if people want to use simple, they can. But I personally prefer exponential because I expect my playstyle to change over time. And by introducing the toggle, we allow you to kind of switch halfway through if you guys want, which I think is a really cool option. Um, but anyway, I just wanted to show you guys this to show this concept of memory and how it updates. And so if I go back into here, what I just showed you that line is one entry in this list. We do this for every single one of the connections in the neural network so that each of them get updated. Right? So for example, some of them are corresponding to what you did in the bottom left quadrant. Again, this is just an illustration. It's more complex than this. Um, but So what's going to happen is that you're going to have memory that's like specific to this. And if you showed it what to do when you first started playing the game and it started training, if you use the simple approach, it's going to get anchored to always doing that in the bottom left corner when you use high lambda. And by using exponential, what you allow it to do is you allow it to basically change a lot. These like red lines, you allow it to change basically um, its memory over time. I'm trying really hard not to use the technical terms, but I really hope that that makes sense. If anyone has any questions, please let me know.
This is exciting stuff. I think most of our members are on board. So no question for now.
Cool, cool. I mean, that was basically it. That's all I kind of wanted to show you guys for today. If you guys want, I can train my model. But that was the main thing I just wanted to update you guys with. More cool updates coming soon, but that was I was just we have some other smaller ones. Like we increased the hit stun for knockback because we found that some AIs it seemed like they were exiting hit stun early or what appeared to be early, so we just extended it a little bit. And we're currently working on some other kind of physics fixes to make the game feel even better. But that'll probably get updated in next week's session when I do kind of like a full like training session.
Reggie say that is a cool update too.
Awesome. Awesome. No, we have some really cool updates coming up. Keep an eye out for the next week. It's going to be exciting.
Super cool. So I guess for this session, like if you would like, we can either wrap up here and let people try the new update, or you can maybe demonstrate that some of the stuff that you know
Sure.
that allow you to train with this new function.
Sure, sure. One thing I'll note is that it won't be immediately apparent um, because it takes a few time steps for the memory to get updated. But I can certainly kind of like hop into here and show you guys. I might do like a few training sessions. I haven't actually. I mean, I've tested it out over long periods of time, but I haven't over a short period of time. Let's go back into the inspector. I'll just restore my model. Okay. I'm gonna want to, so I have exponential memory off. Why don't I do a few sessions? Hold on, let me think through the best way to do this. You know what? Why don't I save this for next week? Um, because this will probably take me like half an hour to figure out how to showcase it best. Um, I mean, it works, but I just don't know exactly how best to showcase it in like a small period of time. Because as I mentioned, the updating only happens kind of after you save, and then we're like basically after you save, then we update the memory, and so you have to do it maybe like 3, 4 times for it to really become apparent, as you saw in like the um, as you saw in the graph, that it takes some time for the drift to kind of take place. Like for example, let me hop into here. So at at this point, can I like zoom in? Um, yeah. So at this point, like it's not immediately apparent that like, for example, at like 52, it's like at 6. Here at 52, it's still around 6. Um, and it might take, for example, like it going to like at 64. Let's hop into 64. This is around like 10 and this is around like 7. So it starts to really showcase a difference, but really over time, maybe at like 80 and 80 over here, this one's just like at 9, this one's at 16 or 17. Now you're going to really see a difference in trading, but you'll notice that the kink happened at 50 and it takes like 30 training sessions to really see a difference. So it's not going to become super apparent like in a short period of time when I'm demonstrating it on stream. You know what I mean? Um, I can try and think about how to best showcase this over a very short period of time. Um, but yeah, it I don't think I'll be able to do it within like 20 minutes. You know what I mean? If it takes like 30 training sessions to really take effect.
Gotcha, gotcha. With that being
Um,
said, maybe maybe this would be the wrap up for this session.
yep.